gentlemen, today's class recording has started. So, remember that for the last day of school. Yesterday,
I think that's a threat.
it'll be beneficial to you. Remember that for the last day of school.
Quiz about
Well,
Clapping?
your last day of school, you will take your semester exam. So maybe like the last day of class.
so is that going
How
to
many
be
times
part of it?
You better start taking notes.
How are you starting tracking for it?
Yesterday, we started talking about atomic structure. And we talked about how through the work of Rutherford and Thomson, Rutherford's students and Thomson, we found out that the atom really isn't the smallest piece of matter out there, that there are pieces smaller than the atom themselves. And we call them subatomic particles, because sub means below, right? So, yesterday we talked about 3 main subatomic particles. Somebody tell me about one of those subatomic particles. Okay? Hannah, go ahead. Proton. Somebody else tell me a characteristic of a proton. Positive charge. Somebody else tell me the location of a proton. In the nucleus. So protons, positive charge in the nucleus. Next subatomic particle. Which one do you want to talk about next? Electrons, right? Somebody else tell me a characteristic of electrons.
They're negative.
They're negative charge. Alright, so they're negatively charged.
They got negative personality.
Okay. Where do we find electrons?
The electron cloud.
The electron cloud. What did Rutherford's experiment tell us about the electron cloud? There's not much there, right? Couple of small electrons, but mostly empty space. Alright, third subatomic particle we introduced yesterday was neutron. Characteristic of neutron. No charge. Where do we find neutrons? In the nucleus. Densest part. Good. Here, this table, we said, was a comparison of our different subatomic particles. We talked about the idea of the relative charge and the relative mass. If we label something as relative, what are we doing? We're comparing it, but we're not necessarily doing what? Getting an exact number or measuring it, right? We're comparing, but not exactly measuring. Somebody tell me about one of the comparisons that this table shows us based on this data. True. Tell me one of the comparisons that this table makes for us. What's one piece of information we can get out of this table? Tell me something about the relative mass that you can. Tell me what you know about relative mass based on that chart. Something specific. Do you want somebody else, Katie? Abby, go ahead. Compare something for me based on this information. There's a bunch of different comparisons we can make with this data. Give me one of them. You want somebody else to take it over? No, I want you to. Okay, I want us to apply this definition. Scott, go ahead.
So the electron is 1/1836th of a proton.
Good. Meaning that the electron is how big compared to a proton?
Not very big.
Not very big at all. Okay, that's one comparison that we can make based on this information. Hannah, what's another one?
Proton has like one positive neutron.
Okay, so proton has a positive charge, neutron has nothing. Let's maybe compare the proton and the electron. What is this telling us about the charge of a proton and an electron? How much positive and negative charge do they have? The same, right? They have the same amount of positive and negative charge, meaning that essentially they could do what to each other? Basically cancel each other out. What's one more comparison that we can make based on some information in this table? Let's say there's one more. Neutron has no charge. I would say the other comparison we could probably make is from the mass column. What's the other comparison we could probably make? Elizabeth wanted to answer the last question. Elizabeth, go ahead.
I think it would be that protons and neutrons have the same relative mass,
Protons and neutrons have the same relative mass, meaning what?
meaning that they're
The same what?
that's what I don't know.
Okay, they're the same size or mass, right? We could say that they are basically about the same size or the same mass. Good with that? Go ahead.
For the relative mass in the electron,
Yep.
is it always going to be the proton or the numerator?
Essentially, if these numbers in the relative mass fraction here, if those numbers represented something, yeah, the 1 would represent proton, and the 1836 would represent electrons. Basically, that if for every 1 proton, we would have to have approximately 2,000 electrons, or a little bit less than 2,000 electrons, in order to balance out the mass. Okay. So yeah, if you wanted to think of it that way, that would be fine. Okay. All right. Yesterday we started talking about how do we tell one atom apart from other atoms. And we introduced 2 terms that we use to classify or describe atoms. Tell me one of them. The atomic number. What does the atomic number tell us about that atom? Hannah, go ahead. How many protons it has. Why is that important? Go ahead, Hannah, you can finish this one off.
Because it also shows how many electrons it has.
Okay, that was sort of a secondary thing. It also tells us the number of electrons. Why is the number of protons important? True. It tells you how positively charged it is. What else does it tell us? It's in a way, yes.
It tells us how unstable it is.
Maybe. It tells us what kind of. It tells you. Yeah, I mean, those are pretty absorbent paper towels, though. Be careful. It might soak up the table itself. They're so important, so powerful. Okay, so the atomic number tells us how many protons an atom has, and that's important because that determines what kind of an element it is. And we'll talk about that a little bit later on. So it distinguishes that atom as a specific element. Okay? The last term that we introduced yesterday, can be confusing. What is the name of the last term that we introduced at the end of class yesterday? Mass number. Okay? Even though it says mass number, you can just hold on to it. You don't have to actually hold them. You put them on the desk or on the floor. That's fine. So, even though mass appears in the name of mass number, what does the mass number actually tell us? Daniel, go ahead. The sum of the number of protons and the number of neutrons. The mass number is a count. It is not a measurement. Mass number will always be an integer because we just count up the number of protons and the number of neutrons in the nucleus. Even though it has mass in the name, it's not a measurement, it is a count. That will be important as we move on. Good so far? Question mark. All right. Let's go. We are going to skip Roman numeral number 7 in your outline and go straight to Roman numeral number 8. Although I want you to make a change to the title of section 8, or Roman numeral number 8 of your outline. Notice your outline for number 8, it says identifying isotopes. I want you to change that to say identifying atoms. There are 2 ways that we can identify an atom. The first involves a name and a number. And so you can see up here it says element name dash mass number. So here's what I'm going to do. I'm going to try and do this real quick. All right. So let's go here, and let's say an atom is given a name. Oh, I don't want purple on the of oxygen 16, just like in your outline. From the name oxygen 16, we can tell how many different subatomic particles are in this atom. First, the fact that we call it oxygen will tell us two important things about it. Okay? Oxygen to what? Yeah. No.
It's oxygen.
Nope. All right. So the fact that it's oxygen, we said, Alex, what determines what kind of an atom something is? The number of protons. Any atom that we call oxygen will always have the same number of protons. What tells us the number of protons that an atom has? The atomic number. So, go to your periodic table. Find oxygen on your periodic table. Okay. If you find oxygen on your periodic table, you will see that its atomic number is 8. And so if oxygen's atomic number is 8, that means that it has 8 protons. And I'm just going to use that symbol to represent protons. Okay? So in the little line next to oxygen 16 on your outline, let's start off with 8 protons. Okay? All right. Atomic number tells us the number of protons. However, we said the atomic number could also tell us what? The number of electrons. Atoms have to be electronically neutral. What does that mean? Same protons, same electrons, because the positive charges have to be balanced out by the negative charges. So if oxygen 16 has 8 protons, because it's oxygen, it also must have 8 electrons. And I'll use that symbol, right, lowercase e with the exponent to the negative to represent the negative charge. Okay, here's where we have to do some reasoning. According to your outline, the number after the dash is what? The mass number. Okay? So here, this number here is the mass number. What does the mass number tell us? Number of protons plus neutrons. It is a count. There are 16 total protons and neutrons in the nucleus of this atom. Of that 16, how many of them are protons? 8. So the rest of them have to be neutrons. To get us up to 16, how many neutrons are there? 8. So this atom, calling it oxygen 16, we should be able to figure out that it has 8 protons, 8 electrons, and 8 neutrons. Okay? Good for starters. Okay. The next one on your list is chlorine 35. So the first thing we can do is go to our periodic table and find chlorine. It's over on the right-hand side. Finding chlorine on the periodic table, we can figure out what chlorine's atomic number is. What is chlorine's atomic number? 17. If chlorine's atomic number, any atom that we call chlorine has an atomic number of 17. What does that mean? 17 protons. 17 is chlorine's atomic number based on the periodic table, and that means it has 17 protons. But If it has 17 protons, what else does it have to have? 17 electrons as well. To be electronically neutral, you have to have the same number of positive charges as you do negative charges. Okay? Good so far? All right. Now, this number, right, is the mass number. Mass number is a total. Protons plus neutrons. Of this 35, how many of them are protons? 17. So that means the rest have to be neutrons. So how many neutrons are there in this atom?
18.
There will be 18 neutrons. Notice, protons and electrons have to be the same. But do neutrons have to be the same as the other two? No. Sometimes it is, sometimes they are, and that's okay, but they don't have to be. All right? For example, the last one that you guys have on your sheet is uranium-238. Okay? So first thing we have to do is find uranium on your periodic table. It's way down at the bottom. Way down at the bottom. All right. What is uranium's atomic number?
92.
92. Uranium's atomic number is 92. That means it has 92 protons. What else does that mean? 92 electrons. Those two have to be the same. Okay? Good? All right. But, like we said, that number is the mass number. Mass number is a total of protons plus neutrons. So, how are we going to figure out the number of neutrons here? Use your calculator, that's fine, right? What are you going to type into your calculator?
238 minus 92.
238 minus 92, right? This is the total. 92 of that total is protons, so that means the rest have to be neutrons. 146 neutrons. So trend-wise, small atoms like oxygen, what are you seeing about the number of protons and neutrons in a small atom like oxygen? Pretty much the same. Once we get a little bit bigger, like chlorine, what starts happening? What starts happening to the number of neutrons compared to the number of protons? Getting a little bit bigger. But once we get to big atoms like uranium-238, what are you seeing about the number of neutrons that we have here?
It's real big.
Way bigger, right? It's almost 1.5 times. It's actually more than 1.5 times the number of neutrons that we have protons. Okay? All right, good there? Okay. There is a shorthand way that we do this. And it's the next section on your outline, but I'm just going to do it up here. Okay? Actually, I should show you this first. All right. So the shorthand way we do this involves one symbol and two numbers. These are just generic variables that we use to represent things. Like X in this representation represents the elemental symbol that we get from the periodic table to represent a specific type or kind of element. Then Z represents the atomic number. Don't yell at me, I'm not the one who decided that Z should represent a word that starts with A, and A should represent a word that starts with something else. That wasn't me, don't yell at me. Okay. So A represents the mass number, but Z represents the atomic number. So a combination of a symbol and two numbers can also represent that atom. Do we have this written down? Okay. So first, let's apply this to something we've already done. Then I'll give you a new one that we haven't done yet, and I'll show you how that works. Okay? So let's start with this oxygen that we started with. Okay? So we're going to represent this atom, instead of calling it oxygen 16, we're going to represent it as a symbol with some numbers. So we look on the periodic table, and the first thing we find is oxygen's elemental symbol. What is the symbol that we use to represent oxygen? O. So we're going to start, big letter O, just over on the side. You guys can just write this sort of like on the side of your outline, or on the same line that you wrote 8 protons, 8 neutrons, 8 electrons. That might be a good place to write this. Okay? All right. Then, 2 numbers. So we got to fill in these 2 bubbles. Okay? What number goes on the top, in the top bubble? The mass number. Here, that was the number that appeared after the dash in the name. So we're going to put 16 up on the top up here. Okay. And then, what number goes on the bottom? The atomic number. The atomic number for oxygen is 8. So, we would represent this atom like this. Okay? Good there? Okay. Let's come down here. We find chlorine's symbol that we use to represent chlorine on the periodic table. It's what? Cl. Now, one thing. We'll start good habits right now moving forward. Okay? Take a look at all of the elements on the periodic table that have 2-lettered symbols. What are you noticing about the pattern of those 2-letter symbols? First one's capitalized. Last one is not. Okay? That's important. When you are writing element symbols that have 2 letters, you must capitalize the first one, but you must not capitalize the second one. Okay? For instance, I'll give you another one later on. Okay? So, when we are writing symbols, capital, lowercase, that's it. If we have an element that only has 1-letter symbol like oxygen, it's got to be capitalized, although O is a little hard to tell. All right. So, 2 numbers that are going to go next to this symbol. What number are we going to put on the top of this sort of kind of a fraction that we have to make over here? 35 is going to have to go on the top because that's the mass number of this atom. What number is going to go on the bottom? 17, because that's the atomic number. Okay. All right, good there? Okay. Let's pull out the sheet that I gave you today, the one that you picked up off the red tray. And let's take a look at a couple of examples here and what I want you to do. Okay? So, I will say this before we start doing some examples here. There is not one necessarily correct order that you have to do these problems in. I'm not talking like sequentially 1, 2, 3, 4. I'm talking as we move across a row. Okay? Some of you may fill in the boxes in different order than I fill in the boxes, and that's perfectly fine. Okay? So, let's start with this one right here. Okay? So it'll be 1, 2, 3, the 4th row down on your sheet. Okay? Alright, it gave us 2 values, and it wants us to fill in the rest of this chart, or the rest of the row. Alright. Again, you don't have to do it in my order. If you see it in a different order, that's cool, but I'm going to run through a couple of examples. It told us, here, sorry, I should do this. We're looking at this row of the period, or we're looking at this row on your sheet, okay? All right, it gave us an atomic number. What does the atomic number tell us about the atom? The number of protons, right? That's the first thing. So, if we know the atomic number is 4, automatically we know the number of protons is also 4. But, what also has to be 4 in this row? Electrons also has to be 4 because the number of protons and the number of electrons have to be the same. They cancel each other out. Okay? All right. The second number that they gave to us is a mass number of 9. What is the mass number? What is the mass number described for us? Neutrons plus protons. We have 9 total protons and neutrons. Of that 9, how many of them are protons? 4. 4 are protons. So what does that mean about the number of neutrons? This has to be 5. Alright, good so far? Okay, now let's do the last two over on the left-hand side. Isotope designation. We could also call this atom designation if we want to. Okay? The atomic number tells us how many protons an atom has. That's important because it describes for us what type of an atom this is, or what element this atom is. Go to the periodic table. Find the element that has an atomic number equal to 4. What do we call that element that has an atomic number equal to 4? Beryllium. Okay? So this will be a beryllium atom. However, we're not done. We will find out, probably at the beginning of class tomorrow, that there are different beryllium atoms out there. We said that when we write names of something, we have a name with a dash and then followed by a number. What number comes after the dash in the name of this atom? 9, because this number here is the what? Mass number. So we write the name of the element followed by the mass number. So this atom is beryllium 9. Okay? Good? So far. Alright. Last, symbol. We say we start off with the symbol of the element that we're talking about. What is the symbol that we use to represent a beryllium atom? Be. Capital B, lowercase e. Then we said there are two numbers that go to the left. The top number is the what? The mass number. For this particular beryllium atom, what did we say the mass number was? 9. So 9 is going to go on the top. And then what number goes on the bottom? What number goes on the bottom of that set? You can go back to your outline if you want to, right? The atomic number, so for this case it's 4. Again, you don't necessarily have to fill in those boxes in the order that I filled them in, but if you see other connections, if you see other things in different ways, that's fine. As long as we end up with those same answers, that's what I'm looking for. Okay? All right, good? So, before we wrap it up here, if you go to the calendar, like I said, in the homework section down here for Thursday, this link says answers to problem set. If you click on the link, you'll see the answers to the problem set that we just started there. Okay, so you can check out and see how you did. I am not collecting this tomorrow in class. However, the other homework that you have is your quiz. There will be questions like this on the quiz. If I give you an element or an atom name and a mass number, can you tell me how many protons it has, how many neutrons it has, how many electrons it has? Okay? If you have questions about that sheet tomorrow in class, like if you can't figure out where an answer came from, we can do a few more examples in class. No, put those back in the wire, put the periodic tables back because those are a class set. So. Quizzes due, I think I have it due like Sunday night at 11:59. So anytime over the weekend is fine.